Alright, hello everyone. Welcome to our today's lesson on finding patterns. So for the past few units, we worked with clumping polynomials together, multiplying polynomials, all that kind of stuff. Right? So now we're gonna actually move on to being able to put them on the graph. But before we do that, we have to learn some pattern recognition. Right? Because again, math is all about finding patterns and then we using numbers to describe those patterns. So let's take this one for example. Right? Just a simple pattern. 5, 9, 13, 17, and so on and so forth. What's the next number in this pattern? Right, so when we write it out, right, we can see that it is going up by 4 each number. So naturally, the number after 17 is just that plus 4, getting us 21. Right, and from here, we notice that it doesn't really matter which term it is. Right? It could be like the 100th number, 101st. Is that how it works? 101st number. Like it could be the 500th number. Doesn't matter what number of term it is. We're just going up by 4 each time. Right? So naturally, to find the 100th number, we actually don't really want to write all of them out. Right? That's a waste of time. So we can use a equation or find an equation to figure out what the number is. So we can just take the first one numbers that we know. Right. We know that it's going up by 4 each time. Right. Each number is going up by 4 each time. So we're just multiplying by a 4 for each of those numbers. Right. So starting with this first number, right, we just have the 4 by itself. Starting from the second number, we're adding 4 to the 5 to get 9, so it's 2 times 4. Next one is 3, next times 4, and so on and so forth. Right, so in each of those numbers here, we're just adding a 4 to them, right? Which is another way of saying we're just multiplying by 4 each time. And of course, just to complete the equation, we notice here that with the 4 times 1, right, which is 4, we just add 1 to it to get to 5. And it is the same for all those numbers. Right, so we have to make sure that whenever we look for patterns, we're looking for how much it is multiplying by, and then a number that's the same for each of those terms, right? So that they all add up together. Right? So now we notice here that whatever number it is, let's say t here, is just 4 times the term number plus 1. Right, so the n here is the nth number. Right, so the second number is n equals to 2. The second number is term number 2. Right? Or let's say the fourth number, or actually the fifth number here. Right, the fifth number is the fifth term, which is n equals to 5. Right? And as you can see, if n equals to 5, which is the fifth term, then 4 times 5 plus 1, right, is 21. And of course, this works for any term number as well. Right, so the 100th number is just 4n plus 1, and we know 100 just means n equals to 100 plus 1. So the 100th number is 401. Right, so again, we could literally just keep writing numbers until we get to 401. Right, or we can find a general equation that describes this pattern. Right? So now it doesn't have to only apply to just numbers, right? We can look at different things as well. Right, so let's look at the parameter of the 10th shape here. Right, so for the first shape, right, that's a parameter of 4. We got 1, 2, 3, 4. The next shape, we got 1, 2, 3, 4, 5, 6. That's 6. And the next one, 1, 2, 3, 4, 5, 6, 7, 8. Right, so we can see a pattern right away. Right, realistically, we only need 3 numbers. And we're just going up by 2 each time. Right, so let's list them out. So those three numbers that we saw from the pattern is 4, 6, and 8. We know they're all going up by 2 each time. Right. The first shape, we just have one of the 2's already. The second shape, we add another 2 to it. Third number, we add another 2 to it. Okay, and then we fill in the numbers to make all the equations equal to each other. Right, and as you can see, we have found another pattern or another equation. Right, so the 2 at the back doesn't change, but the 2 at the front gets multiplied by the term number. So if you're looking for the 10th shape, or the 10th term here, the 10th shape, right, this is just 2 times 10 plus 2, which is 2. Right, so if we complete this little pattern here, eventually we will get to 10. But again, it's often easier to find an equation for it first, and then just go from there. Right, and now, of course, we can also use a table. Right, looking at just the n here, right, we know that n is going up by 1 each time, whereas t is subtracting by 4 each time. Right, so that's our pattern. So we know something right away. Right? So the t, because the t is going down by 4 each time, then that means it's just going to be -4 times the term number. Right, so whatever term it is, we multiply by -4, and then we add a number that we don't know, a mystery number. Right, and it actually doesn't really matter what. Yeah, so it doesn't actually really matter because, or sorry, it doesn't really matter that n is what n is. Right, all we care about with n is that it's going up by 1 each time. Okay, so now here's what we have. Right, the t is going up by -4 each time, or going down by 4. Right, so it is just n times that difference. So now we have to figure out what goes here. Right, and to do that, we can just plug in any of the sets. Right, we know that when n is 0, t is 5. Right, when n is 0, t is 5. Right, and of course, I should probably use an actual variable here. Let's say the mystery number is a. Right, so t is 5, and n is 0, times that by 0 plus a. We essentially just get 5 equals to 0 plus a, so a is just 5. Which means that the equation is -4n plus 5. Okay, and that's it. And just for fun, we can double check this, right? If n is 4, oops. Right, if n is 4, we can plug that in. Right, so -4 times 4 plus 5. That's -16 plus 5, which is -11, which is what we have here on this chart. Right, so sometimes we're given all the information, right, but we have to kind of work backwards to figure out what the equation is. And of course, we can put in a word problem here. Right, so we got a flower shop here renting out bouquets of the Silent Princess flower. They're charging $35 per day. And $0.1 for every flower that we're giving out. Right, so we can use the table of values first. Right, let's say there's no flowers given out. Right, but because they're charging $35 per day to use the service in the first place, so even at 0 flowers, the cost is $35. And if we give out one flower, we just add $0.1 to it. 35.1. Right, and then for each subsequent flower, it's just 10 cents. Right, just like that. And now if we want to give out 156 flowers, how much would that cost us? So, when we see a big number like this, we can always just find an equation first. Right, so once again, we know that it is the difference, right? It's going up by 0.1 each time. So it's going to be 0.1n plus a number that we don't know. And now, what is a number that we don't know, right? The number that doesn't change, right? We can see that because we're starting with $35 a day every single time, right? That's a number that doesn't change. That's a number that we start with, right? So think of this number here, right, as a quote-unquote starting number, right? Because we know that every single time we want to rent out those flowers, we have to pay $35 no matter what. So we can actually plug the numbers in just to find the same answer anyways. Right? So let's take, for example, this case. Right? The n is the number of flowers that we give out, which is 0. And the t, right? If n is 0, then t is 35. Right? We're just taking this first set of numbers here. Right? As we can see when we plug it in, 35 equals 0.1 times 0 plus a. Right? A is still 35. Okay, from here, if we want to give out 156 flowers, then n, is then 156. Right, so we just plug it in. T equals 0.1 times 156 plus 35, which is $50.60. Right, just like that. Right, and as we have done from the last few units about solving for x with polynomial, we can go backwards too. If we spent $135 on the flowers, how many of those flowers did we give out? So in this case, we're given the t, which is $135. Now we just plug it back into our equation. So 135 is 0.1n plus 35. This is a two-step equation. Reverse operations on both sides. Right here, we can divide both sides by 0.1. So n is 1,000. Right, so we gave out 1,000 flowers and paid $135. Right, and of course, we could also multiply everything by 10 as well to get the same answer, right? Multiplying by 10, we get rid of the decimal. Okay, yeah, that's about it for today though. Right, so for pattern recognition, right, we always look for what's the common difference, right? So how much are we increasing or decreasing each time? And for cases where we're given a chart like this, right, we can tell right away what the increase or decrease is. Now our job is to figure out what this initial number is right there. Okay, so with that being said, that's about it. Good luck practicing.